Hello everyone. In this session, we will discuss the efficiency calculations of the three-phase induction motor. So, in order to calculate the efficiency, we have some different models. So, we will discuss that models. These models are useful to find out the efficiency very easily. So, in that first model, when the input is given, so generally the input is given, you know that the input is nothing but the stator input. We will take the input of the induction motor is nothing but the stator input. Input means how he given. So this is the three-phase induction motor, and the input is applied to the this three-phase supply, that it will be applied to the stator, and we will collect the output. Generally, this three-phase input is electrical input. Electrical input means he will give the voltage, and he will give the current, and he will give the power factor. Otherwise directly he will give the power. Okay, so generally the given are always in line voltage, line current, and power factor. So if he is not given line, directly he given voltage and current, then you should consider itself those are the line values. Okay, so then the stator input is, I will write like this, the stator input is root 3 times the line voltage and line current into cos pi 1 by 1000, pi 1 by 1000, then it become kilowatts, then it become the kilowatts. Here what are the things? VL is the line voltage, VL is the line voltage. Here the IL is the line current, IL is the line current, and cos phi 1 name itself 1 represents always stator, so we will write the stator input power factor, stator input power factor. Okay, so these are the things we have to consider. After that, and with that he will mention some losses, so you should always mention the PSL. PSL means stator losses, the name itself, the stator losses. YP, P means power, he mentioned the stator losses. Then we can find out the stator output. By using the losses we can find out the stator output. The stator output is nothing but the rotor input, or nothing but the air gap power. How we can find out this? We have the stator input minus, by doing the stator losses, we will get the stator output, and from this we can find out the rotor output. From this we can find out the rotor output. How we can find out the rotor loss? So you know the relation between, generally the rotor loss, sometimes rotor loss is not given, no problem at all. If the rotor loss is not given, for example, then what we have to follow? We can find out gross mechanical power developed directly without having the rotor loss. Generally what is our requirement? We rotor input will given to the rotor, rotor has some loss, for example this is the rotor, and it will develop the gross mechanical power developed. But we can directly find out how. You know the formula of gross mechanical power developed, that is 1 minus S into air gap power. That means by multiplying with this factor, you know the relation between the gross mechanical power and the air gap. That relation equal 1 minus S into air gap power. So by using that formula, we can directly find out the gross mechanical power developed. And we have one unknown is there. That unknown is the slip. And we can find out the slip by so many methods. So generally first method, sometimes in the question he give you slip directly. He given the slip is directly given sometimes, no problem at all. In the second case, sometime he mentioned the rotor speed is given. Sometimes he give rotor speed is given. That time we can find out the slip. That slip S equal, we have directly formula ns minus nr by ns into, we can find out the slip. Or he can mention the rotor oscillations. Sometimes he mention the rotor oscillations, rotor frequency. Sometimes he mention the rotor frequency oscillations. That time we use this formula, that is the rotor frequency is, we can write number of oscillations per minute by 60. So by doing this we can find out the Fr. After getting the Fr, we can find out Fr equal to S times of slip. From that we can find out the slip value equal to Fr by F. Okay, so sometimes he will directly given rotor frequency is given. Sometimes, so you know the relation between the rotor frequency and stator frequency, then directly we will get that. So, and after finding that, we will directly find out the net power. The net power is like this: gross mechanical power developed minus, we can remove the frictional and windage losses. Frictional and windage losses, this is the F, and WL means, F means frictional losses, because it is a rotating, every rotating machine have some frictional losses. WL means windage, always wind affect the rotating part, wind direction will decide the rotating thing, that's why it will some loss. So therefore the finally we can write the efficiency is like this: net power by stator input into 100, stator input into 100, we will get the efficiency value. Okay, and we can find out the net torque also. How we can find out the net torque? Stator load torque is like this. The load torque we can find out, that is net power by rotor speed. From that we can find out the rotor speed is 2 pi nr by 60. This is the rotor speed. So by using all the things we can find out the efficiency. So you should follow the procedure, because we have number of formulas as available. We can apply the formulas, depends on our requirement, which quantity we require, then we should apply that formula, then we will easily find out the value. Next, we can find out the efficiency by the another model. That model is, sometimes when the output is given, so the output is given directly given, then generally direct output sometimes directly in kilowatts, sometimes he given in kilowatts the output, and sometimes he given in horsepower, sometimes he given in the net power, the output power should be given in the horsepowers. You know the relation between the horsepowers and the kilowatts. Always you should convert these horsepowers into kilowatts. How you can convert? You know the 1 horsepower value equal to horsepower, multiply the horsepower with 746 by 1000, then it will become into the kilowatts. Okay, so we have gross mechanical power developed, you know, that is net power plus frictional and windage losses. By that we can find out the air gap power. Reverse, because he given output, you will find out the input now. So we will follow the reverse, air gap power or rotor input or stator output. How we can find out? Gross mechanical power developed plus the rotor loss. Okay, so you should find out the gross mechanical power directly, and sometimes rotor loss is not given, he will not mention any rotor loss, no problem at all. So you know the relation between the air gap power and gross mechanical power developed, that is the 1 minus s. From that you will find out the stator input, you can find out easily, that is rotor input plus stator input. No, not rotor input, rotor loss. The stator input equaled, so stator loss, sorry, rotor input plus stator loss. Okay, stator loss plus rotor input. By doing the stator loss rotor input, we will get the stator input. So we can find out this rotor input directly by using the efficiency ratio, that is 1:1 minus s. Generally this is the procedure to find out. From that efficiency is directly the net power by stator input into 100. So it should be in kilowatts, don't forget it, it should be in kilowatts, then you will find out the efficiency. Okay, and we have one important thing is the specified power in the problem is output power. So sometimes he is not mentioned directly, he give power, directly he give the power, he will not mention input or output. The power is given in the problem, that means it is output power. It is very important thing, you should assume that is the output power. So by using that output power we will go for the problem. So sometimes he specifically mention, then it is the specifically mention, it will not applicable, if will not mention it will be applicable. Okay, so these are the some models to calculate the output of the efficiency of the induction motors. One model is for input is given, the another model is for output is given. I hope all of you understand the session. Thank you.